Back to my channel. So this is Hardhick. I'm gonna with you today, guys. Today I'm back with another video. So in this particular video, we'll be starting with our organic chemistry for our boards. See, because JEE means has a lot of syllabus. So if we set with JEE syllabus, it will be not be finished. Like I cannot finish it fast. So we are just gonna go with our boards. Sorry, BOARDS boards 23. So let us start the basic. We know what is carbon, where it lies on the periodic table, all stuff. Because in class 10 we have read it. But now as we came to 11, we met with this topic called as hybridization. Hybridization, right? So this hybridization said how the bonds between carbon and other atoms or between two different atoms are formed. So we can understand this carbon has tetravalence, means four bonds maximum it can form. But how? When we saw its the configuration, we found it as to be 1s2, 2s2 and 2p2, right? In this second shell, that is the outermost shell, we found it has two electrons, four electrons and two electrons in the first shell, two in the first shell and four in the second shell. So this is the structure of p p subshell. So we know how to arrange electrons in different subshells, right? So I've arranged four electrons like this. So when I excite this is the first excited state, of the carbon. So what happens? This electron in the uh, p subshell, yes subshell, will go to the the second yes shell. This is the p shell, this is x, y and z. So the s electron one will get excited and go to the vacant orbital of the second the second shell itself. So what I can say, see, once again I'll say, this electrons get excited and it will go to the vacant pz orbital, SPDF. These all stuff we have read in atomic structure. So let us start. So this will be here, this will be here, this will be here, this will be here, where we can see each has, like, to fulfill the valency, each should get one electron, so easily it can form bond with H, each subshell. So what will be getting? One carbon, 4H it forms, that we will say it as methane. This bond that we created here with the help of H atom helps us to understand the topic of hybridization, the sp3, sp2, sp1, sp and all stuff we read, right? So that is C in this carbon one. So bonds, let us learn about the different three types of bonds and its characteristics. So the first bond is the single bond, which we call it as alkane. The double bond is called as alkene, and the three bonds is called as alkyne. So hope you understood alkane, alkene, alkyne in class 10th. So we can say this forms sp3 hybridization. sp3 hybridization, while this ethene forms sp2 and the triple bond forms sp. So sp3, sp2 and sp1. So the what is the steric number of these three? So it's 4, it's 3 and it's 2. Fine. Hope you understood. Yes. So the shape of this is tetrahedral. sp3 hybridization generally forms tetrahedral. sp2 forms trigonal planar, and this thing forms, the sp forms linear. This is the distance of the CC bond, and this is the distance of CH bond. So this is the we can see this trend in periodic structure, right? As bond order increases, the bond length decreases, right? So as bond order means bond order increases, the length decreases. See, in single bond it's 154, double bond 134, and in triple bond it's 120. Similar, the trend or the what do you see? The difference here also can be seen as same here. It's decreasing. It's also decreasing because of the bond length decreases when there is bond order is more. Bond order is directly proportional to bond length. This thing, so this gives us one more, or can say, relation between S character or percentage character to the electronegativity. As there is more S character percentage, there will be more, it will be more electronegative atom. Hope you have understood. See, it has here, we have 25% and 75%. Here we have 33% and 66% 0.33.66. Okay, this is 25, 75, 33.3 and 66.6. Then here we have 50 and 50. So from this we can say this will be more electronegative. Can I do this thing, right? Yes. So this thing you have to keep it in your mind. Next, we know what is pi bond and sigma bond. Pi bond is formed when there is sideways overlap, and pi bond is formed when there is end-to-end overlap. End-to-end means like this. I have shown the structure here. This is P subshell, where you can see the meeting of two here. I have highlighted this point where it's meeting also. Here it's sideways means the shells should be perpendicular to the plane, and it should be parallel to each other. The plane of the atom will be like, or the molecule will be like this, and it's perpendicular also parallel to the each subshell. Then only the sideways overlap is possible. Hope you have understood. Next, this pi bond acts as nucleophile. What is nucleophile? And all this thing we'll be learning in the chapter called as hydrocarbons. That is the next chapter. Next, representation of compounds. Okay, there is four type of representation basically. Dash, condensed, to what do you say, zigzag, 3D, condensed, and dash. In condensed we do have partial and the super condensed form. See, dash bond is nothing but, see, this is your dash bond. Wait. See, where all the bonds between the carbon is shown. This is your dash, while this is partial condensed, this is super condensed. Here only the CC bond is shown, here no bond are shown. The zigzag, this is your, oh wait, this is, no, let us take a different example. Here we'll take C3H6, have drawn two bonds. C3Cr, this points, what you can see represents C atom, and the substitutes are like this. So this is the single bond, but we need only 6 carbons, right? So just think, we can add one more bond here. What is that bond? The double bond. So this and discards this carbon, I mean the bond, and here also one more bond. Sorry, this here also one more bond is gone. Hope you understood. Let us understand zigzag at once, because we'll be using the zigzag representation in nomenclature. So it's very important to understand how to identify the atoms present here, the functional group identification and all is very important. Fine. Next, 3D structure. See, the hybrid structures present in the compounds are not always linear. As I've told, the sp is only linear, rest all are 3D structures. Example, sp3 carbon, which has structure, is tetrahedral. Tetrahedral means like this. So this bond will be towards us. This bond will be like 180 degree to this thing. This will, the angle between them will be 180. You can imagine it. So that is represented by a diagram called as wedge dash bond. This is called as wedge. This is called as dash. This, when we draw it in a compound, this represents that this bond is towards us, while this says it's outwards or away from us. I can say away from us. Right, hope you have understood. 3D is done, zigzag done, condense both partial and super is done, and the dash bond is done. So we have almost done with our half of the basics. This video will be completely basic, guys. The next video will be on the nomenclature, easy topic for boards, so we'll be covering it in one video. So what is the different types of classification we'll be studying now? See, OGC is nothing but organic compounds. So organic compounds are mainly classified based on this thing. One is a structure. So this is your structural classification. Structural classification, where it's classified into acyclic and cyclic. Cyclic, by this we can understand it's a closed structure, while this is an open structure where the ends are not common. I mean, there is no open ends. Here there is open ends, here there is not. There is no open ends. Fine. Next is your homocyclic and heterocyclic. So homo means same. You know what is homo, right? This is same. That means there is no, I can say, foreign atoms in this cycle. This cycle can be like this. There is only CCA atoms here, while the hetero can be like this. See, this is has head N, where rest all are C. Rest all are C, but this is N. This is a what? Other atom that doesn't belong to the C group. So what I can say that this has different atom in the cycle, while this has all same atom. Next, based on that, we will be further classify the homocyclic compounds into two different things: alicyclic and aromatic. I think many people have studied a compound called as benzene, that is H6C6. Its structure will be somewhat like this: alternate double bonds with H, right? This is your HH bond present here. Hope you have understood. So, but what is alicyclic? What is alicyclic? 1 minute, guys. Okay. See, alicyclic is nothing but those those compounds which doesn't follow a rule called as Huckel rule. Huckel rule. So this aromatic compound can be further classified into non-benzenoid and benzenoid. Well, you know what is benzenoid, right? Which has benzene rings in it, which has benzene rings, and which it doesn't have benzene rings. Hope you have understood these classification. Next we'll be classifying the organic compounds based on functional group and homologous. It's not classification basically, but still we have to know what is functional group and what is homologous series. So functional group is a group of atom which helps to give the particular compound its different properties to it, or I can say which is responsible for the chemical properties of the particular compound it is present in. For example, CH3, CH3, CH3OH. Now this OH helps to add the different properties, that is chemical properties, to it. See, CH3 wait, CH3 CH2 and CH2OH. This is the correct structure, guys. Please excuse that was wrong. So this C before it was CH3 CH2 CH3, but after adding CH2 CH2OH, this is different. This is completely different. Why? Because this is there. This is called as functional group for no reason. Means like it gives its properties, special properties for the particular compound. The next is the homologous. What is homologous? Group of or you can say a series of compounds which has same characteristic functional group, and the members of that series, particular series, should be differing by CH2 number of atoms, I mean this carbon CH2, and or I can say 14U by mass. Example, CH4 C2H6 C3H8 C4H10. So these are in homologous series. So when you subtract, you'll be getting the common difference, that is CH2. Hope you understood till now. So that's it for today's video. Hope you have liked my video. Subscribe to my channel, hit that bell icon. See you in next videos. Bye.